Kia ora, Year 11 and 12. This is another old exam question from the summer 2015 Pure 3 paper. Again, we haven't covered this in class yet. If you're watching this around May the 18th, just don't freak out because we haven't done differential equations yet. But do feel free to watch after the trig internal if you want to get a little bit ahead. So what we're given here looks like a differentiation problem, but actually it's all about integration. And we're given a point on the curve, and we're told that when x is 0, y is 1. And we have to solve this differential equation, which looks horrible. But basically, in A level and level 3, we have got one tool in our toolbox to solve things where we have to integrate, and we've got x's and y's all mixed up. Right, so the end result that we're after here is y equals blah, blah, blah in terms of x. Okay, in other words, we're going to get a function of x. We don't want any mixed up x's and y's. And the way we do this is as follows. So we start with dy by dx, all mixed up. But you can see that you've got the x's, you can put brackets around there and you'll see two factors, right? One's a factor which is a function of y, and one's a function of x. Now this feels very weird when you start to do it, but we can split this whole thing up to have all of the y's over here, and all of the x stuff over here. Right, and so you see what happens there is the dy just sits here and we divide this through, so that's why we get 1 over. And then here the 4x sits here and we times through by the dx, and then we integrate both sides. And that's basically how you're going to solve all differential equations this year. Now looking at that, this side is fine, so we can integrate this straight away and we'll get 2x squared plus c. Now that's very straightforward, that's just using my power rule backwards from last year. Over here though, this is a big yucky mess. Why? Well, we know that it can't have come from the log of the bottom line, right? Because if I differentiate this, I would get 1 over 3y squared plus 10y plus 3, but by the chain rule I'd have a 6y plus 10 sitting in the top line, and I don't. I just have a 1. So it's definitely not coming from that function. So let's just erase that because that's just a big mess. So what I've got in the denominator here is a quadratic. And we can see that we can factorize that quadratic. And then we can split this up using partial fractions. So we're going to leave the integration sitting here like this just for now and come back to it. Now we're going to go to work on the left-hand side of that equation. We're going to remember all the stuff we did in term 1 about using partial fractions. So the first step is to factorize this, and it factorizes very easily. We've got 3y times y, we've got a plus and a plus. So if you just stare at that for a second, hopefully you'll see that it factorizes like this. And what we want to do now is to write 1 over 3y plus 1 times y plus 3 as a constant over 3y plus 1 plus a constant over y plus 3. Because if we do that, integrating this is going to be a piece of cake, and this as well. And they're both going to have a natural log in them. So let's think back to how we did partial fractions. Well, we've got 1 is equal to a times y plus 3 plus b times 3y plus 1. Now let's substitute in y equals negative 3, and we get this. 1 is equal to 0 for that term, plus b times negative 9 plus 1. So you can see this is not working out to have beautiful numbers. We get 1 is equal to negative 8b. b is equal to negative 1/8. Now the next value we're going to use will make this term 0, so that's going to be y equals negative 1/3. So when we chuck in y equals negative 1/3, we have 1 is equal to a, right, so substituting in here, a times negative 1/3 plus 3 plus b times 0. So 1 is equal to a times 8/3, which gives me an a value of 3/8. Now, please be really careful with this part, because if you screw this up, it's going to get really difficult to solve the problem right through. So just go back and check that you haven't mucked up your partial fraction stuff. Really common mistake here is to see people write in a hurry, a is equal to 8/3. You've probably seen me do that on the board numerous times already. Okay, so just be careful. Now we can split into partial fractions. So let's look at what we're trying to do. Well, we're going to go back to this step up here. We're going to rewrite the fraction with the quadratic as two little fractions. Just do that now. So we have 1 over 3y plus 1 times y plus 3 is equal to 3/8. Just let me have a wee check. I'm not going wrong. So 3/8 times this minus 1/8 times 1 over y plus 3. So we can write that out a bit more nicely, but what we're going to do now is put it back into the integral. So we've got 1 over this is now being rewritten as follows. It's the integral of 3/8 times 3y plus 1 minus 1/8 times y plus 3 dy. And we'll put a big bracket around all of that. Now we can integrate those pretty quickly. This one is going to come from the natural log of 3y plus 1. And it needs to have the scalar of 3/8 there. But when we differentiate this using the chain rule, we get a factor of 3 out that we don't want. So we reverse that out by timesing by 1/3. Hopefully by the time you watch this video, you will have done that lots and lots of times, and this step here should feel pretty comfortable. Then we're going to do the same thing with the next bit. So we're going to have minus, well, we've got 1/8 of log of y plus 3. Now this time when I differentiate the inside function, I just get 1. So I don't need to have any kind of simplifying out factor there. Now you're probably wondering, if you are watching this ahead, why has she done this with the absolute value things? And I'm not going to go off on a tangent about that now. I will talk about that lots in class. Okay, but when we integrate and get back to a log function, it has to have a positive domain, basically. So we always impose this condition that we're working with the absolute value of whatever stuff's inside here. And you're also probably wondering, why has she not put a plus c here? And I'm going to talk about that very briefly now. Back up at the start, I had this arbitrary constant over here. Now, when you've got a constant of integration, it's kind of like a placeholder. We could have one over here. We'd have a plus c1 here, and we could have a plus c2 here. We're going to use some specific conditions, which will be my point on the curve, to figure out what these values are. But we can combine those into an arbitrary constant of c2 minus c1. So in practice what that means is when I'm doing a differential equation problem, I just have to chuck in 1 plus c, and I usually put it over here on this side just because it usually works out easier, but it doesn't really matter. Okay, so we don't have a plus c down here, and what we know is that this left hand side is equal to the right hand side, which is 2x squared plus c. Right, so that plus c is not there. Now let's clean up that big mess. We've got negative 3. No, we don't. We've got negative. We've got no negative. We've got 1/8 log of 3y plus 1 minus 1/8 log of y plus 3 is equal to 2x squared plus c. So we've got down to here. We've still got a wee way to go because we want to get y equals blah 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 in terms of x. But you can see that we no longer have x's and y's all mixed up, and we've got no derivatives sitting there. So we're going to combine the logs now into 1/8 of the natural log of 3y plus 1 over y plus 3. And that equals 2x squared plus c. We could keep on working this through, but it's a good place to stop and go, hey, I can work out what the plus c is because I know that 0, 1 is on the curve. So I'm going to sub in y equals 1 and x equals 0. So we get 1/8 of log of 3 plus 1 over 1 plus 3 is equal to 2 times 0 squared plus c. So that gives me 1/8 of log of 1 is equal to 0 plus c. 0 equals 0 plus c, so c is a very exciting 0. So that's good, because now I can go back to here and simplify this a little bit more again. We're just about there now. We've got 1/8 of the log of 3y plus 1 over y plus 3 is equal to 2x squared. Multiplying through the 8, I get this. So don't skip any steps in here, because it's really easy to muck them up. There's 16x squared. And the last step is to, I guess, exponentiate both sides. So we get 3y plus 1 over y plus 3 is equal to e to the 16x squared. But we're not finished, because we were asked to get y in terms of x. So we need to have, for our final answer, y equals blah, blah, blah. Now this was a 9-mark question. I can't remember how the schedule worked, but if you got this far through, you're probably up to 6 or 7 marks already. There's just one little bit left to think about. So how can we deal with this and get y equals? Well, look, we've got a 3y here, and we've got a y plus 3 here. So I'm going to try and get a constant out of that. So let's make this something over y plus 3. And we're going to try and get a 3 factor coming out here. So I've got 3y plus 9 minus 8 is equal to e to the 16x squared. Now that's really going to help us. I've got 3 minus 8 over y plus 3 is equal to this. And you can see that we're just about there with a little bit more manipulation. What do we get now? Well, 3, where do we go now? We can put this and this together. So negative 8 over y plus 3 is equal to e to the 16x squared minus 3. Think of this as one factor, and this is one factor. Negative 8 over e to the 16x squared minus 3 is equal to y plus 3. I can hear you groaning down the computer at how much work this is, by the way. But you kind of know that by now. Lastly, we get y is equal to, let's change that into 8 over 3 minus e to the 16x squared, take away 3. Okay, so I think that's a perfectly good final answer. However, we could go on and simplify it a bit more and get a common denominator, and that would look nicer. So let's do that for some practice. I bet you've all turned off the video. Right, there's 8 minus 3 times that. Right, if you are still watching, I bet no one else is, you can come and tell me and claim your pineapple lumps. So we get negative 1 plus e to the 16x squared. We've lost a 3, there's my 3 there, plus 3e of that over this. 3 minus e to the 16x squared. Yuck. Right, 3e to the 16x squared. Now I'm really just playing around to make it look nice, guys, okay? So you don't have to do this. But if you look in the mark schedule, this is the final answer that they come up with. I'm pretty confident that you'd get 9 well before that. So you definitely get the full marks for that. But there's no logical reason why that's bad. I think that would also get full marks. Okay, thanks for watching, if you still are, and I'll do some more exam questions over the next couple of weeks.